Okay, so 2.4, what is the main topic in 2.4? Everybody look at their book. What is the main topic there? Yes.
Opposites.
Yes, we're talking about opposites.
Opposites.
Okay. Now, opposites have a lot of different meanings. We're talking about opposites in numbers. Okay. So when we talked about the problem in 2.2, it was 1.6, I think, where you had to make a graph in a chart, and I said the opposite of x squared. Okay. It was the opposite of x squared plus 4. I'm using that term right there, the opposite. Okay. Basically, opposites are things, how do I say it? Okay, so if I have a positive 1, the opposite is a negative 1. Okay. The positive 5, its opposite is negative 5. And the reason where that comes from, why we call them opposites, is our numbers on a number line go, if I'm going to the right, they're going positive. If I'm going to the left, they're going negative. But if you look at positive 1, that's going in the positive direction. The opposite is going 1 in the left direction, and we call that negative 1. So it's a directional sign. The positive says to go to right. The negative actually means to go to the left from 0. This is from 0. So here I go positive 1, that means I'm stepping to the right 1. This is negative 1 because I went to the left 1 step. Okay? If I go 5 steps up here, that's the same as going negative 5, because this distance is the same as this distance. The distance is the same. This is just telling which direction we went. So really a positive and negative are directional signs. Okay? They are when we graph or go on a number line, it's how far they are to the left or how far they are to the right from 0. That's what they're really talking about. Okay? So, if you talk about this, if I have the opposite of negative 1, well, that means go the opposite of that. Well, what's the opposite of negative 1?
1.
It's positive 1. Okay? So this is how you read this. This is the opposite of negative 1. So when when a negative sign is out there all by itself, it's read as opposite. Okay? So this is read as opposite.
Or negative 1.
Yeah, you can
But then
say
there's
that.
negative.
Yeah, well, then you have to keep going the opposite, the opposite, the opposite, the opposite. Okay? So, but when you're using it here, this is the opposite of negative 1. That's how you read that, which is positive 1. Because if I go the opposite direction of going this way, I would go this way 1. Does that make sense? If I went the opposite of going negative 1, I would actually go in the right 1, which is positive 1. Okay. So that's what we're looking at. Okay. So, one thing we can find out, this is kind of a rule, if you have a number, this is the general rule. A general rule is given in variables. That's why we start to learn algebra, is because we're trying to make general rules. If we have A, then its opposite is negative 1 times A. So if there's A, then the opposite is negative 1 times a. Notice that.
Why not negative a?
That'd
You
be-
could say that. Negative a is equal to negative 1 times a. That also works. Okay. That's
Oh,
another
yeah.
way. Negative a is the same as negative 1 times a. It's another way
That's
of
like
writing
just
it.
saying like 1a, but like different.
Yeah, it's just saying when you have the negative in front of it, it's really being by negative 1.
But it could be
Oh,
negative
one.
1a.
No.
That's with a, yes.
Yeah.
If you have another letter, it's not that.
Yeah.
Okay, A is just a generalization, okay? No, I don't really go with those, okay. This is always an interesting one. I'm just gonna show you it works with distributive, okay? This next one kind of puts this idea of opposites together with distributive. So this is what we have, and I'm gonna start with numbers to show you with numbers. If I have the opposite of 4 plus negative 7, okay? What it's really saying is, I'm really, remember, negative can be the same as multiplying by negative 1. Does that make sense? So we could say this is negative 1 being multiplied or distributed to both things. Okay? That's one way of looking at it. You're multiplying by negative 1. Another way, so if I multiply by negative 1, it will be negative 1 times 4 plus negative 1 times negative 7.
Negative 1 times negative 7 would be negative 6, right?
What's a negative times a negative? So when you do negative times, so here it's a negative times a positive, so what's my answer? If it has a negative times a positive, think of it as the opposite of 4, what would it be? Yes,
Negative 4.
that would be negative 4. This is the opposite of negative 7. What's the opposite of negative 7? Yeah,
7.
yes.
How do you know
Okay.
that? It's like you've taken the
So
class.
you can say negative 1 and negative 1, okay? Or this could be read as the opposite of 4 and negative 7. So it's the opposite of each of those inside, okay? So there's two ways. Some people, it makes more sense to multiply by negative, okay? A negative 1. Some people, it's easier to say, oh, I want the opposite of 4 and the opposite of negative 7. Okay, now the question becomes, what if I have, I'm going to write it as 4a minus 7, and I put an opposite there, okay? Do you remember that subtraction is the same as adding a negative?
Yeah.
Okay, it's the same as adding the negative. So here, that is 4a plus a negative 7. This is just a different way, if I wrote that there, this is just a different way of writing that same thing. Okay, these two things. And I take the opposite, it would still be the opposite of 4a, which is negative 4a. By the way, you don't take the opposite of a. We just take the opposite of the number. Or we take opposite of a, but you only take the opposite of the term itself. Don't take all of it. Don't do it to both of them, okay? The opposite of a negative 7, again, is a positive 7. So it's going to come out to basically the same thing if I had a's here, here, and here. So we get the same thing. So if it's a subtraction, what I tell people is now that we are in algebra, we are not going to add the negatives like that. What we're going to do is just write a subtraction because mathematicians are lazy. They're not going to add plus minus. They're not going to write both of those. They're just going to write a minus and assume you know that's the same thing. Okay? So you have to learn the shortcuts that mathematicians take, because when we first start talking about adding, we put the negatives in there like that. But now, we don't put it both there. Because we defined addition or subtraction as adding the opposite. So this and this mean the same thing. A negative sign really means that's -7.
You're a mathematician, so are you calling yourself lazy?
I am. I am lazy. Because I don't write down all these things either.
But isn't every person technically lazy in a way?
Some ways, yes.
So we're all mathematics.
You are! Look at that! See, you're all mathematicians! Good job! I like it. Okay. You guys are so funny. Okay, so now we're going to section 2.5 today. Okay, that was all about it's really not a whole lot. Now we're going to 2.5 and we're looking at this. Okay, 2.5 is about testing equivalence. Those are big words, okay? Testing equivalence. Okay, the first thing we need to know is what equivalent means. Okay. Equivalent means basically they are the same expression written in two different ways. So equivalent expressions is really saying the same thing in two different ways. If you want to think about it in our English language, it's really that they're synonyms, right? A synonym really says the same thing as something else, just using a different word. Well, in math, equivalent expressions expressions are basically synonyms of each other. They say the same thing. So basically, if I say that 2a minus 4, if I have that, or I have 2 and a minus 2, are they equivalent? Now, using our distributive property, can we tell if they're equivalent?
Yes.
Yes. We could work it out using our distributive property. We could distribute this, whoops, and see if we get that. That's one way of testing our equivalence. Work out to see if you can get the same expression. So can I make this expression to like that, or can I make this expression like that? If you can do one or the other, and they are the same, then we know they're equivalent.
But
So
it doesn't look similar because that's 2 times a minus 2, and 2 times a minus 4 is not the same.
not the same thing. Okay, so this is one way. If you can make it like distributive property, that's one way of testing equivalence. Okay, but the easier, more basic way is to check numbers in there. Okay, so the way we're talking about in here is if I have two expressions like this, that's one expression. The other expression, I'm going to erase this really quick, is going to be,
Wait, do we not want that?
no, that's one. I'm checking that expression versus this expression. Okay, now, I'm looking at those and I'm saying, okay, are they the same? Well, what we do is we put in numbers for n. We don't want to choose one most of the time, but sometimes you can choose one and see if you get the answer. But you should use at least 3 different numbers for n and check and see if you get the same things.
So we're almost doing like a table.
Yes, you're almost doing like a table. In fact, you are doing like a table. Okay? So I'm going to put 1, I'm going to put 2, and I'm going to put 10, just because I wanted to do something different. Okay? So here we got 1. So it's 1 squared plus 5 times 1 cubed plus 2 times 1. Okay, what is 1 squared?
1.
1. It's 1 times 1, which is 1. What's 1 cubed? If I take 1 times 1 times 1, what do I get?
1.
1, right? 1 times 1 is 1 times 1 is still 1. So 1 times 5 is going to be what?
5.
5. 2 times 1 equals what?
2.
2. So for this one I get 6, 8. Okay, now I'm taking 1 times n plus 5 times, 1 times 1, 5 times n squared plus 2. Okay? What is 1 times 1?
1.
1 plus 1 squared is what?
1.
1 times 1 is 1, times 5 is 5, plus 2. I'm going to add those up and multiply it by 1. 1, 6, 8 times 1 is 8. They give me the same answer, don't they? Sometimes when we use 1, it will give me the same answer, so you need to check other numbers. So I said let's check 2. So this is 2 squared plus 5 times 2 cubed plus 2 times 2. All I did was put a 2 in each spot. So 2 squared plus 2 cubed plus 2 times 2.
They're the same.
What is 2 squared?
4.
Okay. Here's a question for you. What is 2 cubed? Mason.
2 cubed?
2 cubed.
What do you mean a cube?
What is a cube?
Oh, you mean cubed, like
Yeah, cubed. 2 cubed. What does that mean?
2 times 2 times 2.
That's right. 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 is 8. So this is 5 times 8 plus 2 times 2, which is 4. Okay. What is 5 times 8?
45.
Yeah, it's 40.
It's not 45.
4 plus 40 plus 4 equals what? Now we're taking 2, whoops, times 1 times 2, I'm just going to put 2, plus 5 times 2 squared, plus 2. What is 5 squared? It's 4. Is that right?
Yep.
Okay, so I get 2 plus 5 times 4 plus 2.
We'd get 48.
I get 20 here, plus 2, so this is 24, because this is 20 plus 2 is 24. 2 times 24 is also 48.
When can we take a break?
Just a
We'll
minute.
never get a break.
No, you will get a break. So, it looks like, and then you could check a third one just to make sure, okay?
I think they're all the same.
They are. The only thing you need, so to prove this is true, we can show it by some examples that doesn't necessarily mean they're equivalent, but most of the time it does, okay? If I find one that doesn't work, just one of them that doesn't work, then they're not equivalent. So they'll say, give me a counterexample. A counterexample is one that shows that when I put a number in here and put the same number in here, they don't equal the same. Does that make sense? So that's what you're looking for. And right now, we're just doing it by putting numbers in. We will eventually get so we can do it by these or by graphing. We'll start showing you how to graph these, and then you can see if they're the same. If they're the same, they will draw the same line. They're equivalent. Okay, it will be the same picture on a graph. So go ahead, take a break right now. We'll come back and we'll do